Let's shine a flashlight at a mirror. See how the light beam bounces back? That's called reflection, when light hits a surface and changes direction. The incoming ray is the incident ray, and the one bouncing off is the reflected ray. If we draw an imaginary line straight up from the surface, that's the normal line. Here's the rule. The angle of incidence equals the angle of reflection, always. That's why you can see your face in a mirror. Light from you hits the mirror and reflects back to your eyes. So whenever you look in a mirror, you're watching reflection in action. Light bouncing back perfectly. Let's shine a light through water and then through oil. When the light beam enters water, it slows down and bends toward the normal. Now, when it passes through oil, it bends too, but not by the same amount. That's because every substance has a different refractive index, a number that tells us how much it slows light down. Light travels a little slower in oil than in water, so it bends slightly more. We can see the incident and refracted wavefronts change direction at each boundary. Even though the speed and wavelength change, the frequency stays the same. That's refraction, and it varies depending on what the wave travels through. Refraction follows a special rule, Snell's law. We measure the angle of incidence, θ1, in air, and the angle of refraction, θ2, in glass. The law says n1 sine θ1 equals n2 sine θ2. Draw the normal line straight up at the boundary to measure angles correctly. Different materials have different refractive indexes, n. That's why lenses bend light just right. Snell's law ensures that light travels along perfectly predictable paths. Here come some straight water waves. When they pass through a narrow gap, they spread out. This is called diffraction, the bending of waves around edges. The smaller the gap, or the bigger the wavelength, the more spreading you see. That's why you can hear someone talking even around a corner. Sound waves diffract too. Diffraction helps waves explore everywhere, even places they can't see. Thank you for watching. Any doubts, comment down below.